Hi, my name is Ian McClarty. I'm president of phoenixNAP. And with me today is David Holder, pre-sales consultant for SUSE. Today, we're going to go over to how to become a Kubernetes Jedi with SUSE Rancher. First, I want to thank everybody for your time, and may the fourth be with you today. Today, our giveaway is going to be an R2D2 French press coffee maker. Please, at the end of the session, we'll announce a winner. It shows in at random. To start, let's have a couple of polling questions. The first one is, does your organization use Kubernetes? We have 4 options here. First, fully adopted Kubernetes deployments, yes. But B, in the process of adopting, yes. No, but it's part of our strategy, so you're thinking about it. At some point in time, you want to do it. And not at the moment. It's not something that you're considering doing. Please select an answer, and then one of the things that we're doing throughout the session is sharing the results as well in real time. And when to close the poll. So let's look at this for a little bit. So interesting here. Obviously, there are people in attendance that don't have any incline yet, but there are, it seems like the majority of people have either some fully adopted solution or are in the journey already or are thinking about it. So that's good. So most of the audience is actually in some level of journey towards Kubernetes. Second poll question. What has made your Kubernetes adoption the most challenging? And look, I'm looking for the thing that is the most limiting right now. Lack of skilled staff, IT infrastructure limitations, legacy monolithic applications, data security concerns, or all of the above. And we'll give a couple seconds here to answer the poll, and then we'll share the results. Okay, let's close the poll down. So interesting choice here between lack of skilled staff. That's definitely very much in tune, but the all of the above is very resounding, and we do hear that quite a bit in the industry. You know, the first thing that always comes to mind is I don't have the staff with skilled talent to be able to do this implementation or this work. But then once they do have the staff or when they're working on the hiring, there's always these other limitations that pop up. So that this validates a lot of information. Thank you. And with that, we'll take a quick state of the union on where we're at with Kubernetes today. So this is relatively fresh information from the CNCF Foundation's annual survey. It closed out last year at 2021. It's only a handful of months old. So first off, number one is Kubernetes is going mainstream. A lot of, as you can see by the poll results, 66% of people roughly have some level of journey. They're either there or they're going there with Kubernetes. There is a lot of movement under the hood for Kubernetes. So managed services for Kubernetes, and Dave will cover some of the landscape on CNFC itself, how big that's grown. But there is more opportunity there and more growth as well. Applications are definitely going cloud native, and they continue to do that. But one of the key pieces here that we need to highlight is the developer burnout. This is becoming a real factor. It is an uphill battle for a lot of organizations because they lack skilled talent, and it's not so much on the developer side. It's that the responsibility either has expanded for a software developer that is going more DevOps now, and now has to worry about their Kubernetes deployment, their clusters, or they have to integrate with groups that are new that have to do this. A lot of times migrating the legacy app to a cloud native application adds a lot of overhead and burden. It's becoming, it's definitely a pain point for a lot of organizations. But there are ways to simplify that, and these are some things that we're going to cover today to kind of ease some of the pressure off and help, and so that the software developer community really can focus on what they do well, which is software development. And obviously, for cloud native and the cloud native concepts, there's an ecosystem of things that go along with it. But anytime we can make the developer focus on writing code, it's to the benefit of everybody without having to worry about all the other pieces that go along with it. So again, a quick snapshot of some market trends. And again, some of this information validates on the poll. A lot of organizations today are evaluating Kubernetes. Doesn't mean they're using it, but they're definitely in some kind of evaluation mode. They're thinking about it. When they say 70%, 74% in production, it really doesn't mean that you have everything in full production Kubernetes clusters today. It means that you have some level of project, or there's some application that is within Kubernetes in your organization. Especially in big organizations, this is very true. If you look at them as they migrate a project or two, or they migrate some workloads, it's to kind of gain expertise in it and gain experience. And so this is definitely a good validation point. Now, this is interesting too, that organizations today don't run Kubernetes in one type of setting. We find that Kubernetes is being run really in a hybrid setting, meaning on-prem, public cloud, different flavors in between of infrastructure. And so Kubernetes is meant to be run anywhere on any platform, and that there's a lot of value there, and the organizations are taking advantage of that. And the other interesting piece right here, again, kind of validates this with a hybrid setting, is that about a third of those workloads are running in public cloud only, which is interesting. But you look at half the workloads are really running about in a hybrid setting of some sort. And again, it depends on how you classify public cloud. And if you look at the workload Kubernetes, you see because of the low instance of like Journey, right, where you have one or two applications that are actually in Kubernetes, 38% are running 5 or fewer deployment workloads, which means they're kind of just kicking the tires, they're testing it out. So it's still a journey for a lot of organizations to be in Kubernetes, and the poll results kind of showed that. Only about 19% of attendees here actually were running were fully in Kubernetes today, or fully cloud native application, right? The majority of people are really in a journey mode right now, in experimentation mode, which means that there's a lot of opportunity here for everybody, and really a good opportunity for the market to embrace this new technology stacks. Again, this is interesting too, because it's interesting that the community that just attended, and also the market kind of goes hand in hand with some of these things. Now, obviously, we didn't have, when this top challenge of adoption, the all of the above option was not there. I do believe that if it would have been set up that way, it would have been, we would have seen more of the IT skill side of the house being the biggest challenge. It really is lack of skill talent that is the biggest limiting factor right now. And anytime that that a provider or our technology can help to make it easier for organizations to adopt Kubernetes, and cut some of the time of expertise and some of the time of understanding, and simplify things, so that really at the end of the day, the developer can focus on getting code out and applications out in a timely manner, and in align with the business. It's the benefit of everybody. And so this is also interesting that this data in the general market validates some of the poll data. Now, we kind of touched a little bit on-prem and the hybrid approach, public cloud. There are definitely different challenges associated with each one. Storage is a very big limiting factor in public cloud, and not because it's not available. It's because the ready states and the understanding of how to make that state more flexible and also more resilient. You really have to have a good understanding of how the public cloud provider does it. And so storage is a limiting factor in multiple facets. Performance is definitely one of them as well, and you have to do a lot more heavy lifting there to get it to a better state. Complexity is another one that is on the top one for public cloud, and we'll go into more detail on why that is in a little bit. But from a high level, in order to be able to take advantage of Kubernetes in a public cloud environment, you're also dealing with a public cloud overhead on top of that, meaning the public cloud ecosystem itself, whoever the public cloud provider is, doesn't matter. They have their own way of interfacing with them as an infrastructure provider. So you have to also add that overlay, that layer on top of that. Yeah, and Kubernetes sits underneath that. And then security is a challenge for everybody. That's just a normal trend. Security is always a big concern for how do you do a proper kernel? How do you do a proper cluster? How do you set everything up so that you're resilient? And how do you set up so that you have good monitoring and visibility into it? So there are different ways to set up public cloud, to set up Kubernetes. Public cloud is one of them. Bare metal is another infrastructure way of doing this. And there are some key differences here. They both have their pros and cons. As you can see, the layer itself is slightly different. A couple of pieces are removed in bare metal servers, infrastructure, or bare metal cloud as we call it. You have a host and a bare metal server are directly tied to each other. Whereas in public cloud, you have a bare metal server, you have a host OS with some kind of hypervisor in there. Then you have a virtual instance that is set up on a VM, and then you have a guest OS inside that with a container on top of that, and then you get into your Kubernetes clusters. So you're adding a couple of different layers, and this adds into that complexity equation that we kind of talk about. So some of the pros on bare metal cloud is you get better performance, you have speed, you know exactly what infrastructure you're getting, and you're not vendor locked. In order to be able to take advantage of a public cloud, you're taking some hits. One of them is definitely vendor lock. Security is a lot more complicated in order to do. You do have better tools in order to be able to do security, but you have to be able to leverage all those tool sets in order to get that. And then obviously, as you take a slight performance hit, not so much that you can't get performance up there, but you have to invest in a lot more resources and infrastructure to be able to get the same kind of equatable resource that you can in bare metal. Since you're adding more overhead and complexity on top of that to what you would typically get in a bare metal cloud system. So there are some actual similarities between bare metal cloud and public cloud. First, they're both very simple to set up. Provision is definitely it. But then the differences kind of get bigger. Upgrades are also very similar in both, but and then there's always ways to interject with both systems in the code stack. So meaning you can use Ansible, Terraform, Pulumi. You can use CI/CD type tool sets to be able to integrate with both of them. You don't have to directly interface with them either, which is nice. Makes it easy. Also, the billing model is very similar. But then the key differences really come into being in a vendor locked environment or no vendor locked environment. In one or the other, in order to take advantage of a public cloud, you really have to take advantage of the different ecosystem pieces that go along with it. In order to do that, then you're really locking yourself up into that vendor. Kubernetes does help with that to kind of free you up a bit, and this is why a lot of people run in hybrid mode. But then you're adding overhead on top of that, so there's always a trade-off. With bare metal cloud, you also get a very transparent configuration. You know exactly what you're getting infrastructure-wise. In public cloud, you get like some kind of like labeling system, like an M2 or a system of I'm gonna big or small t-shirt size. At the end of the day, though, you're not guaranteed exactly what kind of VCP you're getting or how much allocation. And it's also in a shared environment. That's the other reality. So these host clusters, they're very shared, and they can be oversubscribed. So that's where you take small performance hits a lot of time when you do apples to apple comparison. You're also stuck in a very t-shirt size way of doing things, very rigid. So customization options are very limited or none. And then in bare metal cloud, you have a little bit more customization on top of that because you also know exactly what you're getting. So you can right-size your workload a little bit better as well as time goes on. And with that, I'm going to hand it over to Dave. He's going to go over Rancher itself as an option inside the Kubernetes cluster.
Brilliant, thank you very much. So the way I want to begin this is kind of start with the journey that a lot of our customers go through. So when organizations are adopting Kubernetes, they might spin up a couple of clusters, and this is fairly easy to manage. The administrative overhead isn't particularly troublesome, and these are typically on a single provider, so you have access to the various tooling in that provider. But the complexity comes when we start to span different environments, and I come from the old kind of virtual machine infrastructure world. I spent a lot of time as a VMware consultant, and for those who do manage virtual machine estates, you'll understand that VM sprawl is a problem. Container sprawl, on the other hand, takes that to an entirely different level. And we typically see organizations use multiple different cloud environments. So it's very common to see, for example, leveraging existing investments in on-prem infrastructure for use of vSphere or other hypervisor, but then also using cloud environments. And there's a number of reasons why we see customers do this. Sometimes it's for the separation of environments. So we have customers, for example, that will have their production environment on a cloud service and their dev and test environment on another cloud provider. They're also used for separation of tenants. So perhaps different teams, different organizations, different customers will get different clusters on different cloud providers. And sometimes different cloud providers are used or different environments are used because they have different capabilities. So we're seeing a bit of a resurgence where I am at the moment in the use of bare metal clusters, particularly in the field of AI and ML. So having access to high performance compute and especially GPU accelerated workloads in a bare metal environment is definitely on the rise. But the problem comes with now we have multiple clusters in perhaps different environments. So the administrative overhead and complexity becomes exponentially more complicated. So say, for example, we have clusters in different environments. How do we manage things like authentication and authorization? So on-prem, you may be using something like Active Directory to govern identity and access management. If you're using AWS, you're using IAM and Amazon's own implementation. So how do we manage this in a unified way across our entire platform? Then also we have monitoring, logging, and observability. So we have different clusters in different environments. We need a unified way in order to have visibility of our environments, not only for things like troubleshooting, but for also logging, audit logging, and general observability for the operators and administrators that need to actually maintain these environments. Organizations also have to cater for different teams or even sub-organizations. So we see it a lot with our customers that they will adopt a Kubernetes strategy and they'll need to provision resources either in the form of entire clusters or via something like namespaces as a service to facilitate certain either individuals or teams or other tenants, organizations like that. And this can also be extended for different environments. So we need to have resources allocated to dev, prod, test, etc. And then we also have the ability to decide where we want our clusters to reside based on the capabilities that they desire. So I mentioned earlier that, for example, bare metal clusters are particularly popular at the moment for high performance compute and GPU related workloads, but also we have different cloud providers that offer different capabilities. So we need to have the flexibility to choose which environment best suits our particular workload, be it on-prem bare metal, on-prem virtualized, or in the cloud, for example. But this, again, brings a complexity in terms of how we manage all of these things in a unified way. And that's where Rancher comes in. So this is affectionately called the cube cake diagram. So this is, if you've ever joined one of these SUSE presentations before, you've probably seen this before. But effectively at the very bottom, the foundation of our Kubernetes strategy is based on Linux. It can be SUSE Linux, but it can be kind of any form of Linux. And Linux has pretty much brought in the kind of precursor technologies for us to exploit and use containerized technologies that we now kind of leverage within Kubernetes itself. So on top of that, we have our Kubernetes distributions. So here at SUSE, we have, for example, RKE and RKE2 as Kubernetes distributions. We also leverage cloud-hosted Kubernetes distributions in the form of EKS, AKS, and GKE. And we also have another distribution of ours called K3S, which is designed for dev, branch, and edge-based use cases. And the idea is that it should be rather agnostic. We shouldn't really care what type of distribution we're using on what type of infrastructure, because the commonality between all of this is the Kubernetes API server. So it shouldn't matter if we're leveraging an AKS-based cluster or an on-prem bare metal machine cluster, sorry. They should behave with and we interact with them in the same way. And we do that by leveraging something like SUSE Rancher on top. And this provides the management layer across our entire Kubernetes estate. So when we think about all these different clusters, regardless of where they reside or what workloads are running, there's a common suite of activities or requirements that we need to address. So one of them is, for example, version management of Kubernetes itself. So how do we manage those cluster lifecycle activities when it comes to provisioning clusters, upgrading clusters, performing backups and restores across our estates? We also have a built-in GitOps delivery tool within Rancher now. So this is the ability of pointing Rancher to a Git repo where your applications may reside in the form of something like a Helm chart. And then we can then push these out to a variety of different clusters based on their requirements. We also have RBAC and network policies and other security frameworks that we can implement. So obviously, once clusters are up and running, we need a way to monitor them, to secure them, to identify configuration drift. And in particular, we have a utility that compares how a cluster has been created against a CIS benchmark scan. We also have automation in the form of Terraform. So the Rancher product itself is effectively just an API server with a wrapper UI around it. So we have customers that are leveraging their existing automation frameworks and utilities and tools and pointing it to something like SUSE Rancher to automate a lot of these activities. So going back to what was previously mentioned about developer burnouts, if we can then provide these services in a way that's very easy to consume, it can help developers concentrate on purely creating those cloud native applications. And then other teams that are responsible, for example, security or monitoring, can have the suite of tools and have access to these technologies as they see fit. But you're not forced to use our specific series of tooling. So although we package things like Istio and Prometheus and Grafana, etc., you can use whichever tooling you wish, providing it supports vanilla Kubernetes. Next slide, please. So it's not just about cluster management. So a cluster with no workloads on it is pretty much useless. It provides no value. So there's additional things we need to do, or we have to deploy applications to get value out of using Kubernetes. And you may have already seen the CNCF Landscape picture. It's commonly used to depict the cloud native projects and services that are built in a way that's designed to be cloud native. And this is an example that pretty much exemplifies how complicated this landscape is. So there isn't just one tool for monitoring, one tool for security. There's a whole plethora of different tools, and which you need to choose will depend on your requirements, depends on what kind of environment you're running and what you need to get out of it. So say, for example, if we wanted to use some kind of database service, then we have a variety of different options to choose from. We have some which are open source, some which are closed source. The fact is we can pick an off-the-shelf implementation of a cloud-native database solution to facilitate those kinds of workloads. We don't have to work from the ground up to containerize our existing database engine. There are products and companies out there that are either refactoring, repackaging their known, tried and tested applications to run inside Kubernetes clusters. And just as another example, we have service mesh. So within Rancher, we have the ability to deploy our packaging of Istio, which is something that we support and we take an SLA on. But alternatively, you're not forced to use it. So if you don't want to use Istio in your clusters managed by Rancher, then you can implement something like Linkerd or another service mesh. It's completely up to you. And again, the choice to decide which service mesh or any technology to choose is quite a complicated one. But this is where Rancher is a bit more agnostic, where we open the platform up for you to ingest and to deploy the solutions that best fit your requirements. And then when it comes to security tools, there's quite a wide variety of different tooling. So Kubernetes clusters don't just stop when you get the cluster up and running and you've deployed your applications. You need to secure and monitor these clusters. And there's a whole variety of different tooling to help you with that for things like container registry scanning or runtime scanning and anomaly detection. And again, the main emphasis here is that you can fold in the technologies you wish by leveraging Rancher as that focal point. So this is where Rancher effectively acts as the glue, which can be deployed on phoenixNAP as an example. And this becomes your centralized management plane across your entire Kubernetes estate. So we can manage things like cloud environments, bare metal, edge, any CNCF certified upstream based distribution of Kubernetes. And this is where we can deploy, for example, our own internally developed applications. We can point our automation pipelines. We can augment our clusters by, for example, installing third-party applications, third-party tooling. We can manage our workloads regardless if they're stateless or stateful. And we can use like a GitOps-based approach to manifest this. So you can even use Rancher, simply by leveraging its API calls as an example. So we have customers, for example, that use something like Azure DevOps to configure their Rancher environment, to push applications to certain clusters, to automate things, to initiate builds of software. It's kind of highly extendable in terms of how you want to consume. So this is the bit now where I get to do a bit of a demo. So I'm just going to change presenter to me, and then we will begin. Okay, so what I'm going to show now is by no means an exhaustive list of all the capabilities of the Rancher platform, but it should give you an idea as to, effectively what it is. So this is the Rancher UI into a demo environment I already have up and running. And the first thing you'll notice is the number of clusters that it's already managing. So these are the clusters that this Rancher instance is aware of. So the first thing I want to go over is the options we have when it comes to registering and creating clusters within Rancher. The first option is to import an existing cluster. So say you've already created a cluster via some other tooling, something like kubeadm or some other bootstrapping utility. We can import those type of clusters using the generic type here. So we can import any Kubernetes cluster that is based on some kind of upstream-based CNCF certified Kubernetes distribution, and we can manage it alongside all of our other clusters in terms of things like deploying applications to them, our monitoring stack, logging stack, etc. We can also import hosted providers as a native type. So say, for example, you've already deployed EKS, AKS, GKE clusters, etc., but you want Rancher to manage them, then we would use this option. And the advantage of doing this in a native type as opposed to the generic import type is that clusters, or these hosted clusters that are imported as their native type, they will be interacted with as if Rancher created them. So we can do lifecycle activities with those clusters in terms of replacing nodes, changing the configuration, whereas for imported clusters, we simply leverage or we simply interact with that cluster at the API level up. When it comes to creating clusters from scratch, there's a number of different ways we can do this. So the first option is to use a hosted provider. So again, EKS, AKS, GKE, etc. And what Rancher will do in this instance is it will interact with that cloud provider. It will initiate the various API calls required to stand up a cluster of that type, and it will automatically get registered back to this Rancher instance for centralized management. The next series of options are to deploy a Kubernetes cluster on an IaaS provider. So here we are provisioning virtual machines and installing a Kubernetes distribution on them. So you can either choose RKE1, which is one of our distributions, or RKE2/K3S, which is currently in tech preview, but we're hoping to make GA soon. And what Rancher will do in this instance is it will interact with that cloud provider or infrastructure provider, as it were, and it will, for example, spin up the virtual machines, it will connect them to various networks, it will install a Kubernetes distribution, and it will then wire it back to Rancher for centralized management. So Rancher will do the entire end-to-end provisioning of clusters based on that type. And then lastly, we have custom clusters. So a custom cluster is typically used when you want to have, for example, a bare metal cluster, or you want to create a cluster on a set of virtual machines you don't have access to the infrastructure provider for. And just to quickly go over some of the options, I'm going to pick EC2 as an example here. I just need to select some cloud credentials because obviously we need to interact with that cloud provider. So in terms of defining how we want our cluster to be manifested, we have a number of options here. So with the RKE2 provisioning framework that we're using now, we're actually using Cluster API under the hood. So you'll notice if you have used Rancher before and you've deployed RKE1 clusters, the vernacular is slightly different, and that's respective of the underlying machinery that we've changed to. So the first thing we need to do is define, for example, the anatomy of our cluster. So which virtual machines get created and which roles they're going to assume. So we can be extremely flexible with this and have a variety of different machine pools. And as a basic example, what I can do here is I'll have 3 pools, one that's going to manage my etcd nodes, one that's going to manage my control plane nodes, and one that's going to manage my worker nodes. And I can change the roles as I see fit and define the anatomy of this cluster based on these options. And of course, this can be fully automated as well. So for example, I'll add some etcd nodes and then we'll add some worker nodes. And as this is a AWS cluster, we have options like which region do we want to put this machine pool in, and in which zone in that region do we want to put it in. So we can architect the creation of these clusters to be highly available by spreading them across things like availability zones. As this is an AWS cluster, we can choose the instance type. So all these options are respective of the cluster type. So as this is an AWS cluster, we have instance types and the various AWS vernacular used for that. So T2, C5, etc. If this was, for example, a vSphere cluster, you'd get options that pertain to things like the virtual machine template you want to use and which port group you want to attach it to. So once we've decided how we want our clusters to manifest, excuse me, we can now define some of the cluster options. So we can, for example, define the Kubernetes version that we wish to deploy. We can select a respective cloud provider. So a cloud provider effectively acts as the glue between your cluster and the cloud environment it resides on. So this can augment your cluster. So for example, if I were to configure the Amazon cloud provider for this cluster, and if I were then to provision a service of type load balancer, it would provision an elastic load balancer object. And if I were to provision some persistent storage, it will provision an elastic block storage device. We can also select our CNI plugin that we wish to use, pretty standard options. I won't go through every single option here. Suffice to say, it's quite comprehensive, but something I would like to note is, first of all, registries. So when we pull down images to build up, for example, an RKE2 cluster, we have the option to pull it via Docker Hub, or we can, for example, configure it to pull from a private registry. Now, this option is typically used for air-gapped environments. So we have a lot of experience working with organizations that have to operate their Kubernetes clusters in an air-gapped environment. That not only includes being able to pull various images to manifest their own applications, but to also manifest Rancher and the clusters and RKE2 and K3S, etc. And in 2.4 of Rancher, which was quite some time ago now, we introduced the functionality of zero downtime upgrades. So what this essentially does is it will update the control plane in a way that's non-disruptive to cluster operations. And we can finally tweak this by specifying the amount of concurrency that we wish to use when we perform an upgrade option. So as an example, if we were to provision a cluster and then upgrade the Kubernetes version, we would need to rotate or bring out and put back in nodes within the cluster to facilitate the upgrade. And we can tweak this so we can define how many nodes on the control plane side and the workers node side that can be taken out during these cluster-wide operations. So once we have clusters provisioned, and say, for example, you have clusters operating in different cloud environments, a typical pain point our customers experience is securing access to clusters. So within Rancher, we have the ability to hook up to an external authentication source. So in this particular cloud environment, it's hooked to GitHub. So if I hop to my other environment here, we can see the options available to us. So we can see, for example, we can hook up Rancher to something like Active Directory or ADFS or Azure AD, Okta, etc. And then we can use users and groups from that authentication source and not only give them access to Rancher, but also the clusters that it manages. And to facilitate this, we use RBAC. And RBAC operates at 3 different levels within Rancher. We have global roles which determine what can users and groups do within Rancher as a management platform. So can they create clusters, edit clusters, upgrade clusters, perhaps change some of the Rancher settings? Next, we have cluster level roles. So what can users and groups do to specific clusters? So can they, for example, delete persistent volumes? Can they create namespaces? Then lastly, we have roles that operate at the project and namespace level. So for those familiar with Kubernetes, you'll no doubt know what a namespace is. A project is a Rancher concept, and it's simply a grouping of more than one namespace. So we can take a group of namespaces, wrap them around this administrative unit we call a project, and apply RBAC roles to that. You can also implement your own. So if I were to, for example, create a custom role, we can go extremely fine-grained in terms of what we want to govern access to. So say, for example, I have a group of devs. This might relate to an AD group or an Okta group, for example. And I can say for this group, they can create, list, and get, but not delete persistent volumes. and we can add as many resources as we want. So we can go incredibly fine grain in terms of who has access to what within our Kubernetes estate. And for those familiar with Kubernetes, this will look like the Kubernetes RBAC model, and that's because it is. We simply bring to the surface the native RBAC models within Kubernetes and make it very easy to consume by leveraging an external auth provider. So once we have clusters up and running, we can start interacting with them. So the first thing I want to do is kind of go into one of my clusters here. And there's a couple of things we can kind of do off the bat. So the first of which is we can download a kubeconfig file. So this will download, as the name implies, a kubeconfig file specific to me as a user. So this is the cloud config file is downloaded. It relates to me as a user with my specific token and has all the access rights that have been defined based on the RBAC policies I've implemented. We can also launch a kubectl shell directly into this cluster. So say, for example, I want to do some ad hoc troubleshooting. So I do kubectl get all -8. We can, again, kind of use the Rancher UI to dig into this. And we can also navigate through this cluster using the Rancher UI. So say, for example, if I expand workloads and pods, we can have a look at the pods that are running in this particular cluster. So at the moment, I'm only in the user namespaces, so default for me. So I can have a look at, for example, one of these pods. And there's a few things I can do. So the first of which is I can even tell the logs from this pod. So say I'm doing some troubleshooting, I can have a look, nothing's really logged from this pod, or I can even shell to this pod directly. So say, for example, I wanted to do some troubleshooting, I need to do some forensic analysis or something like that. We can do that straight from the UI, or again, you can use your kubeconfig file and hook up to any kind of additional tooling that you wish. We also have built-in metric extrapolation. So we have a monitoring tool built into Rancher where you can deploy to your clusters, and it's based on the Prometheus Kube operator. So if I, for example, go to monitoring, we can see, for example, we have access to a number of different utilities. So say, for example, as an administrator of this cluster, I can open up Grafana. And this is all out of the box. So out of the box, we have access to some very rich metrics to determine the cluster health. We have some at a very high level. So this is at cluster level, the CPU memory disk utilization, or we can go into even more granular details. So say, for example, I wanted to go into the Kubernetes API server specifically. I can have a look in terms of availability of the API server and various other metrics. This can also be used to monitor your own applications as well. So say you've created applications that export metrics in a Prometheus manner, we can then use that, or we can use this stack to monitor those applications. And then finally, the last thing I just want to go over is how we deploy applications, or an example of. So I mentioned earlier that Rancher can act as this glue for you to fold in ancillary products from the CNCF landscape. So there's a number of ways to this, but the main way I want to show is through the apps and marketplace feature. So this is effectively a wrapper around Helm repos. So Rancher comes with 2 by default. I've added the Bitnami Helm repo as well as a third. You can obviously add your own if it's from a third-party community or you're developing applications internally. And what this gives users the ability to do is to perform self-service activities. Say, for example, in this particular cluster, I wanted to install a particular application. I can kind of have a look in terms of the applications that are available. And say, for example, I wanted to install Artifactory, so a container registry, amongst other things. Without having to use my own Helm clients, I can pretty much use the Rancher UI to navigate through this Helm chart, and I can customize the various options. So I can define how I want this particular application to manifest. If I wanted to, in this particular instance, expose it using an ingress, I can edit some of the application settings and tweak it to how I see fit. And then we can use Rancher to manage all of these things. And the last thing I just want to mention is that Rancher as a product, again, is API driven. So everything you've seen here in terms of creating clusters, editing clusters, deploying applications, configuring RBAC, that can all be done by things like our Terraform provider, through other infrastructure as code tools like Pulumi, and also API calls as well. And with that, I will hand it back.
Thank you so much. So David covered a very good interface there that shows also the power of Rancher and Kubernetes in a very hybrid approach. I mean, it basically becomes I know you mentioned glue a couple of times, David, but you know, it really is a glue between physical, between virtual resources, between resources with different providers and vendors. It's very agnostic is a better way to put it. And it is a powerful tool because a lot of complexity that is within Kubernetes simplifies down to simple interface. But if you want to go deep, it also gives you the ability to be able to do that. With that, I'm going to go over a little bit about what differentiates our bare metal cloud offering, along with the SUSE Rancher implementation that we've done. One of the things that is very important about our bare metal cloud deployments, and this is bare metal cloud in general, is that the deployment stacks are under 60 seconds. Now, when it comes to Kubernetes stacks, because there are so many systems that we're deploying and giving multiple host environments delivery on the node side, then it becomes a 5-minute endeavor. But this can be done by API or by a CLI, very similar to how you interface with Rancher. It can be very simple, or it can be very complex. We give you the advanced features behind it. At the same time, we also give you the ability to be able to have dedicated resources. So that is one key differentiator between bare metal cloud infrastructure that we provide as phoenixNAP, is that it's dedicated to you. There's no noisy neighbors. It's available to be performance based, but you get all the value from public cloud, like the hourly billing models, the relatively instant quick and deployment stacks, integration with. We've taken an approach on the CI/CD side to really work on the CD side of the house and implement with multiple modules, and I'll show you that in a couple of minutes. And then there's plenty of repos also. If you want to get really deep in the technology and you want to do more software development around it and expand it out, we have multiple SDKs available in different flavors, whether that be Ruby, whether that be Go, or Python even. So we make it as easy as we can to interface within the phoenixNAP bare metal cloud infrastructure in multiple ways. And so we give you options on how to do it. So the key, one of the things that we pride ourselves is the integration work that we did with Rancher. We simplified it down, made a very easy interface, so that you can do it in if you want, in a couple of screenshots, and I'll show you that. But you can also do it via the API. Our API can also support doing a Rancher deployment, or if you want to do a Terraform script or an Ansible script, you can do it that way as well. So there are multiple ways to do this, but I will show you the more visual way that is very easy. And so what we have right here, we have our phoenixNAP bare metal cloud interface. Right now, I'm already logged in. It's just to get to it, it's just pmc.phoenixnap.com. When you go to it, it'll give you a login prompt. But before I start with that, I also want to show multiple ways that we interface. So we do have a GitHub repository, make the code open source and available. And so some of these different ways to integrate, we're not limiting you to just do a UI interface. You can do it via multiple means on the CD side or orchestration side, or even if you want to develop your own SDKs, we also make that available to interface with. So we try to make as many different points to interject with. So today, if you want to go launch a Kubernetes cluster within bare metal cloud, all you do is click on the solutions area, and we give you the option to create Kubernetes cluster right here. We give you first the option of where you want to put it. And again, you can feed all this by API. How many nodes? We recommend 1 really for testing, 3 really for production is why we split it up. So a 3-node cluster. You get to select what kind of server types you want. So we'll just select some CS2, C1 smalls. But the difference here is we also tell you exactly what kind of hardware you're getting. Again, this is dedicated infrastructure. So you're going to get 3 systems that are 64 gigs of RAM, and also very transparent on what the pricing is for these things, and how much, like what do the upfronts look like, and what are the actual hardware storage looks like. So we're very transparent on what you're actually getting in infrastructure that is dedicated to you. All you have to do is really just give your cluster a name. That can be your own name, whatever you select. Your access keys, you can add your own public keys. I already have some selected. And then we give you different options for the IP addresses that you get assignable to you. And then you can also go into more advanced features. If I just click on create cluster right now, I'll have a cluster deployment in 5 minutes. And the interface that David showed is what your endpoint delivery is next. That's what you would see after this. You would actually have dedicated infrastructure already deployed. and you will be able to take advantage of the interface that David just showed. So I'm going to show you a little bit more of the advanced functionality you can do. And again, these are just parameters you can set. You can select the defaults, or you can select your own SSL certificates or digital certificates that you want to put in. You can taint a node, for example, to have it do a different type of structure. Set up your own cluster domains, and you can do some simple snapshotting and backing up of your actual configuration files. And once I do this, then I'm actually into a create interface cluster, and then I'm done. And then the delivery mechanism for that after 5 minutes is just what David showed. So we make it as easy as possible to interface with a Rancher interface, and this gives you a highly available redundant node cluster with this running RKE. So some of the use cases that we have today for bare metal cloud, and specifically how we see it, production workloads is big. We tend to take a lot of the cloud repatriation workloads, workloads that need to optimization. Kubernetes workloads we like a lot. Those are great. We have developed a lot of native hooks back to Kubernetes, and we continue to develop that and evolve it. Rancher has been a really strong partner to work with there, and we continue to strengthen that relationship and making it easier and faster to do node deployments. Then we also have multi-cloud or edge workloads. Again, VMC is great for these type of workloads that are distributed, that are all over the place, that are hybrid approaches. We like interfacing with the public cloud. We try to make it as easy as possible to do interactions between all the public cloud providers and the bare metal cloud. And really, the workloads that work really well are the ones that need that have some kind of like important mechanism. Like I need a highly performant database cluster, or I need a highly performant Kubernetes system, or I need a very high bandwidth utilization workload that I have that is very expensive to run in public cloud. Those are the workloads that really tend themselves really well to bare metal cloud. Or I have high security concerns. I really need dedicated infrastructure. That's another one. Cloud native tool sets. Again, we have certified Ansible, Terraform, Pulumi modules, and then we have a growing list of other CD-based tool lines that are in play. And then global burst resources. So, there's always a burstability aspect of it. I mean, especially when you offer hourly billing. But you can set it up in such a way where if there's a key a pain point that you're running out of, whether that be CPU, memory, you need to increase resources on the fly. We make it very easy to even augment the existing infrastructure that you're in, so you don't have to tear down your entire environment. You can also upgrade, your processors and your memory stacks with us. So we try to make it as very easy as possible to work and also to scale out your workload. So as we're wrapping up, a couple different things we're going to offer to the community here. First off, if you like to have somebody from our solution side of the house reach out to you and maybe go more deep, we run very high level. We try to make it easy as possible. But if you want SUSE, if you want phoenixNAP, if you want both of us to reach out, or if you're just not interested at the moment, you just want to know more about the technology itself, that's fine as well. But we give you multiple options to interface with us and try to make it as easy as possible. Fill out the poll questions that we'll get back to you. We'll make it in a timely manner. And I just want to thank everybody. And actually, before the questions, we are going to get to raffle time. So let's we can get a winner. And the winner today is James E. That's YEE. Thank you, James, for attending. Thank you for your time, and we'll be reaching out to you to coordinate with you on delivery of your prize. Thank you very much. So some Q&A time. And again, we already have some questions from the audience already, but let me just go through a couple here. And David also, I think we have both for David and myself here. But one of the questions that came up is on the 3-node cluster side of the house. Should it be in the same location? By default, they should be in our environments. You get the best performance there. As you set up multiple clusters, though, they don't have to be. They don't have to be in the same location. The cluster itself should be resilient and should be in a geo-target location, but you can have multiple cluster environments as well. So and you can interface with multiple cluster environments. So the 3-node cluster that we recommend should be in the same geo, the same location, so that you have a strong cluster that has availability and low latency. But as you expand and you want to add more clusters, they can be anywhere. You can also, because the beauty of Rancher also is you can interface with public cloud interface as well. I mean, so you can manage multiple vendors. You don't have to. It doesn't have to be a one vendor management system either. So that is one of the beauties of the technology as well. So this is David. This is a question for David. How many clusters can Rancher manage?
So currently and officially, we support either 2,000 clusters or 20,000 nodes, whichever comes first. We do have some rather ambitious plans. So we're seeing a lot of movement in the edge space, so managing many small clusters. Ideally, we'd like to reach to something like 1 million clusters within a single Rancher instance. That's our target at the moment.
Wow, that's impressive. Another question that came through here. So when it comes to schedule, can I schedule recurring snapshots for my Rancher cluster in BMC? And then the answer is yes, you can definitely do that. We are also bringing into the fold more backup options as well with different vendors that we'll be launching soon. So you'll be able to do more robust backup and restoration aspects of your application as well. So that we're actually expanding functionality on right now. But today you can do basic backups, and you can at least get your configuration files in a good state. Any other questions there from the community? One second. I think we have my exact node at phoenixNAP. I am actually the president of the company, but I like Kubernetes quite a bit. I am a big fan of the technology. I went through the RKE certification itself. Kubernetes certification itself, and I'm very supportive of what is trying to be accomplished by an agnostic technology that works with multiple providers and infrastructure ways. So there's another question here. What is phoenixNAP's business with SUSE? Are you consulting for Kubernetes Rancher deployments or managed service on cloud on-prem Rancher deployments? That's a great question. So we're a pure infrastructure as a service provider, and we provide an easy deployment stack system itself. We do work with Rancher and with SUSE Rancher closer on implementation stacks that may need to be more managed. We ourselves are not a managed services company, but we have developed a lot of automation and a lot of easy ways to integrate. So we ourselves focus predominantly on how do you scale out infrastructure services, whereas Rancher has some really good mechanisms for supporting more complicated workloads. They simplify down, and they have a lot of easy buttons. But when you got to go deep and then really get a managed services engagement, that's really where the delineation goes. We can get you up and running. We can definitely support on some of the basics, but when you need a more detailed managed services engagement, that's really where SUSE comes in. And with that, I want to thank everybody for your time, and also have again happy May 4th, and I hope everybody has a great day. Take care.
Thank you very much, everyone.